spring returns to its original shape after it's stretched or twisted. In the 16th century, springs were used in clocks, and in the late 1800s, they began to be used for chair seats and bedding. Nowadays, they pop up all over the place. We take a look at the unsprung heroes of today's technology. Types of springs include compression, seen here on the right, and extension on the left. During use, these torsion springs will twist at one or both ends. Manufacturing begins with rolls of steel cord. The cord diameters range in size depending on the type of springs being made. A machine called a de-reeler unwinds the roll, feeding it into a computer-guided forming machine. This machine forces the cord through a channel, shapes it into a coil, and then cuts it into segments. Small wheels and a metal shaft guide the cord into shape. These are torsion springs for use in the motor industry. The average car contains around 350 springs. A cone-shaped yellow sensor detects the correct angle of each spring. A good reading is required so the machine can move the next spring forward through the channel to be formed. This machine can produce up to 2,000 springs per hour. Here, another forming machine creates extension springs. A mechanical arm grabs the coil and chops it into segments after it's formed in a channel. As the coil emerges, another mechanical arm steadies it to prevent it from vibrating. This keeps the spring's tension constant, enabling the machine to produce at top speed. In slow motion, you can see how the machine grabs the coil's first ring and bends it to form a hook. This all takes place as the coil emerges from the channel. A vise then secures the last ring on the end of the coil, while another arm twists it to make the spring's other hook. Slowed down, you see how two arms surround the coil being held in the vise. One arm then grabs the last ring, while the other arm twists it upwards. This machine makes compression springs. These have tapered ends and are often used in seat belts. A metal probe detects the correct length of the springs after they're formed. The machine has 4 rotary shafts, called cams. A computer ensures each spring has the desired spec. The springs are also heated to relax the metal. This gives them the ability to retain their shape after flexing. Another machine creates longer, thicker torsion springs. It shapes the cord into a coil with a shaft, and then passes it over a tube to steady it. This ensures the spring will have the required tension. Springs can be as thin as human hair or as thick as a broom handle. An extremely thick compression spring will be required on a train wheel, for example. This machine makes another type of spring. Flexible steel cords, curved or bent at an angle, known as wire forms. These ones, shaped like a W, are used in ovens. This machine's job is to create the spring's hooked ends. This company makes some springs with hooks made of 2 rings instead of 1. Clients order them this way because the hooks are more durable. Custom orders for springs can range from just a few to many thousand. This is another type of wire form. It'll be used in a firearm. Because it's so intricate, it's assembled by hand. 2 base pieces are joined together and placed into a small die. A foot pedal is used to control the die, which bends the segments and completes the assembly. The compression spring's tension is tested using a weight gauge. The correct tension varies depending on what the client wants. To test an extension spring, hooks are added to the weight gauge. Whether they're extension, compression, torsion or wire form, and whether they're inside pens or satellites, these components are always ready to spring into action.